Hi, everyone. My name's John. I'm founder at a project called Astral, and I'm going to see about getting, here we go. I am founder at a project called Astral and a research affiliate at the University of Maryland. And in the past, I've done a number of other things, including worked for the UK's National Mapping Agency Ordnance Survey. I'm a co-founder of a project called Toucan Protocol, and I once spent a summer as a cliff diver at Denver's favorite Acapulco-themed Mexican restaurant, Casa Bonita. For the past 7 years, I've been really interested in the intersection of the geospatial web and the decentralized web. Over the years, I've built about a dozen different location-based decentralized apps, things like transport systems running on smart contracts, sustainability-linked DeFi protocols, location-based games and social experiences. And over the past 2 years, I've been doing research at the University of Maryland, where we've identified 3 pillars that we see as necessary pieces of functionality for an open and decentralized geospatial web to emerge. These are proof of location, verifiable geocomputation, and peer-to-peer spatial data management systems, which together unlock a wild new range of use cases in Web3. So far and away, the most complicated and challenging pillar is proof of location, which is what I'm going to talk about today. The reason that this is difficult is because verifying the position and timing of people, devices, infrastructure, any event is really tricky and it's very subjective. So perfect certainty is not possible. It's a probabilistic spectrum that we kind of call the verifiability spectrum. Different use cases have different needs, and different verifiers accept different forms of evidence. So this opens up a really interesting thorny challenge here. On top of that, of course, complexity is at least squared because where I am right now, where I live, my patterns of life in this world are some of my most private pieces of information. So location verification systems built for Web3, they need to have privacy affordances at multiple points along the life cycle of a location proof. So it's quite a thorny challenge. It's a fun design problem. Now, across the web, location verification is ubiquitous, but right now it's unverifiable and illegible. And so I spent a lot of the last 2 years sitting with this puzzle, trying to figure out how is location checked online and how can we surface patterns there. So techniques like GeoIP lookups, GPS chips, network latency pings, near-field chip scans, collecting ambient identifiers like Wi-Fi BSS IDs or Bluetooth identifiers. All of these are ways for verifying where devices are that are used in location services on mobile devices, on servers, on IoT devices. So our strategy has been to take a holistic view, cataloging these techniques to try to answer an orienting question, which is, on the open web, how can we trust when a claim is made about the location of a person, device, or event? To answer this, we've been building what we call the Astral Location Proof Framework, which is a modular approach to multi-factor location verification to serve the widest range of use cases. The pattern we've identified is, first, a location claim is made, then signals are collected from different proof of location systems. So there's a number of proof of location systems that are kind of out there in the web. Witness Chain is a big one. SpaceComputer is building a really exciting one on their orbital network of TEEs. We're kind of surfacing all of these different forms of evidence and building an open source library of location proof plugins that developers can select as appropriate for their use case depending on the levels of decentralization, the cost of forgery, the privacy affordances. Those are collected and bundled into a set of evidence that we call location stamps. Each location stamp is derived from a single location proof of location system. So when these evidence pieces are bundled together, we stack and compose these stamps on top of each other. Each one makes the proof a little bit harder to forge. That's then processed through an evaluation function, which produces a multi-dimensional assessment of how well the evidence matches the location claim. So we see this location proof as a user-controlled, portable, digital artifact that's useful across blockchains as well as across the centralized web, can be held privately, shared on a server, or published on chain. So this is a new primitive where we've been building the first location-proof plugins now, and we're working on the first combinations and the first evidence functions to bring these to market. We want to bring this new primitive, and we're really excited about all of the use cases it can unlock. Just to say one more time, the location proof, I think of it as a kind of credibility vector. How well does the evidence support the claim? It's a portable artifact, useful across different contexts. There are many different privacy and durability affordances that we're looking at throughout the life cycle of the claim, of the process. One big question we're asking is, how far up the evidence chain can we push verifiability? That's one of the reasons why we're looking really closely at secure hardware to get trusted sensor inputs as far up kind of the signal chain as possible. So the goal is to make evidence and durability legible to humans and machines. We've got SDKs, we've got an API, we're building this open source plugins library, we're building a hosted or managed service for location proof verification as well as geospatial policy analysis or policy checks. That opens up on-chain geofencing and other kind of privacy-preserving location-based applications like Web3 dating apps, Web3 ride sharing. We also do integrations and are building dashboards and decision tools, as well as working on some location-based mechanism design. So there's a lot obviously going on here, and we're really excited about unlocking this ecosystem. I'll flash up a number of things we can build: spatial intelligence tools, local currencies, community organizations based on geography, logistics system, location-based games. It's a really, really versatile base level primitive. So I'm John, this is Astral. We're building the trust layer for location data infrastructure to make geospatial data useful across blockchains and the web. And I'd love to chat if you're interested in building with us. Thanks.